Hello, I'm Dr. Silvia Tedesco, and I'm an associate professor for sustainability within the Center for Sustainable Innovation. That is an innovation hub within Salford Business School. And I'm an engineer by background, and over more than a decade now, I've been working on waste to resource valorization pathways and industrial decarbonization for circular economy.
My name is Özgün Ceren Övinsal, and I am a research associate in biotechnology. My background is in genetic engineering, and I do have a master's degree in biotechnology. I have been working in this project from September with Dr. Silvia Tedesco.
PAPERdecarb is a project that is seeking to investigate and identify optimal ways to valorize paper sludge from the paper recycling and manufacturing sector. The sector actually overall globally produces more than 400 million tons of waste materials, and a part of this material, more than 10%, is actually non-hazardous waste that could be utilized to produce energy prior to being disposed of. And ideally, within circular economy, we don't want to create any waste. We just want to create more steps and manufacturing steps, processing steps that are going to keep the material within use for as long as possible. We have partnered up with two different companies. One is a paper recycling and manufacturer based in Greater Manchester, and the other one is a small SME operating within the construction sector. The project seeks to create an industrial symbiosis between the two companies, where we use the output materials, the waste stream materials from one as an input material for the other. And we are trying to do so by investigating and optimizing anaerobic digestion and biogas production from paper sludge waste streams. Anaerobic digestion is a biological process that utilizes bacteria and microorganisms to decompose waste, particularly organic waste. And during the breakdown process, several different metabolites are utilized by the bacteria to produce a gaseous mixture called biogas. The most important fraction of biogas is methane, which is produced through a biological source, so it's called biomethane. This mixture of gas can be then burned into combined heat and power units to generate green gas and electricity. We are utilizing bacteria, microorganisms, to break down the paper sludge into different organic components, and these organic components are then transformed by a bacterial subset called methanogens into methane, and then we evaluate the calorific value of that methane. Within this project, we have tested two different variables. One of them is the application of an hydrothermal pretreatment, which means applying high pressure and high temperature to degrade the cellulose within the paper sludge into metabolites, sugar metabolites for our bacteria. And the other variable that we tested was to acclimate the bacteria acclimation, which is a sort of an adaptation which happens over a long period of time, where we feed the paper sludge and dehydrolyze the sludge to the bacteria to get them adapt and used to digest this particular type of material. Each individual variable would individually concur to improve the biogas production, and we wanted to test the extent of this and how, and if there was identified there was any interaction between these two variables. Out of our results, what we have identified is that even though the hydrothermal pretreatment is very good at increasing the biogas production over a short period of time, it is not energy efficient over a longer period of time. And so the bacterial adaptation was actually a winner as a strategy to improve biogas production from this material. Through this acclimation, we can still achieve about 5 kilowatt hour of energy per ton of digested material.
Through this project, I improve my knowledge in biotechnology, engineering, and especially in sustainability. from analytical chemistry such as HPLC, GCMS, and analytical and proximate and elemental analysis, along with the microbiological techniques. During this project, we attended many conferences, showcase events, and this way I had the chance to network with the industry partners, and it was great to see that they are trying to be more sustainable.
This project called PAPERdecarb has been funded by BBSRC through one of the BBSRC NIBs called BBNet. If you'd like to know more about PAPERdecarb or you would like to collaborate with us, just feel free to reach out to the Center for Sustainable Innovation.